Hello everyone, welcome to a new episode of CPP tutorial video. Today we will study about Windows C++ synchronization techniques. In almost all commercial programs, we have to apply some synchronization logic for the successful program execution. In Windows, there exist different synchronization techniques. In order to apply appropriate synchronization, you should have a good knowledge about each of the available synchronization techniques. The topic which we are going to cover in this tutorial are a very basic introduction about the purpose of synchronization, different classifications of synchronization, and finally we will touch upon the most commonly used synchronization object in Windows applications. In Windows operating system, a lot of applications are running at same time. Each applications are executing their own code to achieve the corresponding functionalities it is created for. For example, as shown here, media player shall play media files like video, audio, etc. Antivirus software shall provide functionalities to secure your PC from malware or viruses. Most of the applications execute code in multiple threads. For example, as shown here, media player have two threads. Thread 1 may be playing video and thread 2 may be playing audio at the same time. Antivirus have three threads. Each thread might be scanning different drives parallel to each other. In general, inside every process there is at least one running thread. In most commercial applications, programmers use multiple threads to perform a given task for achieving best possible performance. These threads share a lot of data among each other. Some of the threads may be executing mutually exclusive code portions. The primary purpose of synchronization is for controlling the concurrent access of shared data or parallel execution of some particular critical code section in a program. Synchronization is required to be applied in two scenarios. One, to prevent data race, that is, to enable controlled access to a shared data. During multi-threading, in almost all cases, it is mandatory to perform synchronous access to the shared data. Otherwise, data might get corrupted due to parallel write or read operations from different threads. 2. To prevent executing mutually incompatible code or functionalities at a time. That is, prevent execution of mutually exclusive operations concurrently. Instead, the operation shall be executed sequentially in the desired order. An example scenario is parallel file write and file read operation on same file in a hard disk. In a broad sense, synchronization can be classified into two categories. 1. Inter-process synchronization and 2. Intra-process synchronization. Inter-process synchronization means synchronization between different running processes. As shown here, synchronization can be applied between any processes. For example, imagine process 1 is writing some data to a file and process 2 is reading data from file. If both the processes are accessing different file, there won't be any issues. But if they are using same file at the same time, then definitely there would be some synchronization to prevent data corruption. Intra-process synchronization means synchronization between threads that are running inside a single process. In each process, there might be a lot of threads executing in parallel to achieve some dedicated functionalities. Let's consider the same file read or write scenario here also. Here, the file read and write is happening in same process, but under different threads in the same process. For example, thread 1 is performing the file write operation and thread 2 is performing the file read operation. There should be some inter-thread synchronization to avoid any data or file corruptions. Now let's see the different Windows synchronization objects available. In Windows environment, there exist several types of synchronization techniques to achieve inter-process and intra-process synchronization. You need to use the correct synchronization technique considering the time and complexity requirement of the software you are developing. For understanding the time and space complexities, please watch the tutorial about big O notation in this channel. There are certain dedicated synchronization objects inside available in Windows platform. They are critical section to Mutex, third one is Semaphore, and finally fourth one is event. Critical section. Suppose in your application you have to perform write and read operation to and from same file. In this case, let's assume that thread 1 is performing the write operation and thread 2 is performing the read operation. As you know, if there is no proper synchronization between the two threads, the data might get corrupted or cause invalid or partial data to be written or read. For such a synchronization between different threads within a single process, you can use critical section objects. Critical section is used for intra-process synchronization. That is, to apply synchronization between different threads within the same process. Critical section object is dedicated for inter-thread synchronization within same process. Critical section objects cannot be shared across process. You cannot use the critical section to achieve inter-process synchronization. Critical section is not a kernel object. That is, no kernel space is used here. It is just a normal process scope object that have existence only inside the process in which it is created in. That is why the critical section object cannot be shared among process. You can create critical section object in Windows using Win32 type critical section or MFC type C critical section based on the type of your application. MFC version is a wrapper class over the Win32 type, which avoid need for manual initialization and destruction of critical section. Mutex. Let's consider the same example we considered for critical section. The scenario is that we have to perform write and read operation to and from same file. There is a difference here. The write operations and read operations are performed from two different processes, say writer.exe and reader.exe. As you know, if there is no proper synchronization between the two processes, data might get corrupted or cause invalid or partial data to be written or read. For such synchronization between two different processes, you can use Mutex. Mutex stands for mutual exclusion. You can use Mutex object to protect shared resource from simultaneous access by multiple threads or processes. Each thread or process must wait for ownership of the mutex before it can execute the code that access the shared resource. Mutex is primarily used for inter-process synchronization. Even though it can be used for inter-thread synchronization, when used for intra-process, mutex have some performance penalty compared to critical section. So it is better to use mutex for inter-process synchronization and give preference to critical section object if it is for inter-thread synchronization only. Mutex is a kernel object. Because it is a kernel object, it became possible to access the same mutex using its name from different applications or process. It works based on some reference counting mechanism. You can create mutex object in Windows using Win32 API create mutex or MFC type C mutex based on the type of applications. Semaphore. In some scenarios, the program needs to allow access to a particular shared resource or code session of multiple threads or processes. In such cases, you can use Semaphore. Semaphore is another type of synchronization object. For example, in every restaurant, there are some fixed set of dining tables for serving food to customer. There is always a limit. Let's assume that the restaurant have only 10 tables which can serve up to 40 customers at a time. If a new customer comes to the restaurant and its all tables are already under use by other customers, the new customer have to wait until a table or chair is free. Once a customer finishes and leaves the seat, making it free to occupy, the waiting customer can enter the restaurant and start using the facilities. For such use case scenarios, allowing multiple threads to access a given shared resource at a time, you can use Semaphore objects. In C++ applications, it may be used to limit the number of sockets requests to be processed or to limit the amount of process memory, etc. The Semaphore object is useful in such situations for providing limited number of threads or process to use a shared resource at a given time. It acts as a gate that limits the number of threads sharing the resource to a specified maximum number. Semaphore object can be used for both inter-process and intra-process synchronization. The difference between Semaphore and Mutex is that Mutex allows only one owner of the synchronization object, whereas in Semaphore, it can allow up to a specified number of parallel threads or processes to access the shared resource. Since it is a kernel object, it became possible to be accessed from different application or process. Similar to Mutex object, Semaphore also works based on reference counting mechanism. You can create Semaphore object in Windows using either Win32 API create Semaphore or MFC type C Semaphore based on the type of application. Event. Event is another type of synchronization object. Sometimes an action has to be triggered only when some event happens. For example, if you have a dog in your house, it usually stays calm, that is non-signal state. Once an unknown person visits your house, the dog starts barking, signaling you that someone is approaching your house. Then the housemates get notified. By the time people in the house see him approaching, so if it is a guest, then one person in house open the door, another start to prepare a drink, while another person in house may start arranging the house a bit. That is, one event signaling can activate different threads at a time. So as the name suggests, event objects are to be used for responding to such event-oriented scenarios. Events are unlike mutex. Mutex do not have the signaling options. You can use an event object to protect a shared resource from simultaneous access by multiple threads or processes. Other words, you can use event to make different threads to wait for a particular trigger. Once the event is triggered, then all the threads become active and performs its operation. An event works based on its current signal state. The signal state may be manual or automatic depending upon the event declaration. The event signal state can be signaled or non-signaled. When the event becomes signaled, then the corresponding wait function returns, allowing the thread to access or execute the shared resource or critical code sections. If the signal state is currently non-signaled, the thread have to wait until the wait timeout or event gets signaled. The event shall be signaled or non-signaled from another thread inside same process or from different process. Event is also a kernel object. This allows different processes can have reference to the same event objects. You can create event objects in Windows using Win32 API create event or MFC object C event based on the type of application. This table shows the overall comparison of all synchronization objects we just studied. In this tutorial video, we have discussed about the purpose of synchronization, commonly used synchronization objects in Windows environment and its important points. Hope you liked the tutorial. Please let us know your doubts, suggestions and comments in the comment section below. If you are not yet subscribed to this channel, please do subscribe. Also, press the bell icon for getting notifications about future videos. Please do like and share with your colleagues. Thank you for watching the video. Have a good day.